Hello, my name is Victoria, and today I will be focusing on question 2 and answering the 3 following questions in regard to the graph I will be presenting. The first question asks us to state the x-intercepts. For graph A, we are going to observe where the line crosses the x-axis. Wherever point our line intersects with the x-axis is where the intercept is located. For this graph, we are able to see that our line intersects with the x-axis 3 times, giving us 3 intercepts. These intercepts are located at -4, 0, -0.5, 0, and 1, 0. We are now going to state the x-intercepts for graph B. It is noticeable that there are 2 points on the graph where the x-axis intersects with the function. Remember, when a function intersects with the x-axis, the point of intersection is where the x-intercept is located. The x-intercepts of this graph are located at -1, 0, and +4, 0. We are now going to state the x-intercepts of graph C. Here, the function intersects with the x-axis at 2 points. These points are at -3, 0, and +1, 0. Finally, we are going to state the x-intercepts for graph D. We can tell that the function intersects with the x-axis twice. The 2 x-intercepts of this graph are at -5, 0, and +3, 0. For the second question, we will be stating the intervals where the function is positive and where the intervals are negative on the function. In order to do so, you must identify where the positive and negative intervals are located on the graph. And this is where you are looking where the function is above the x-axis and below the x-axis. For example, the first positive interval is when x is greater than -4 and less than -0.5. You can tell because the function is above the x-axis, meaning that it is positive. When it crosses -0.5, 0, which is the point, that is when it enters a negative interval. There is another positive interval on graph A, and again, the way that we identify this is we have to look at the graph and identify where the function is above the x-axis, because above the x-axis is a positive region of the graph. So now that we have done that, we can see that there's an x-intercept at 1, 0. Now, this means that x has to be greater than 1 and less than or equal to positive infinity. And we know that it goes up to positive infinity because the function, or I should rather say the line, moves upwards and it comes off of the graph, which is the graph telling you that the function is never ending in the first quadrant where it is positive. Now we are going to identify where the negative intervals of graph A are located. So remember, we have to look at the graph and identify where the function is below the x-axis. So the first negative interval is located when x is less than -infinity and greater than -4. And the second and final negative interval for graph A is when x is less than -0.5 and greater than 1. Now we are going to identify where the positive and negative intervals are for graph B. So remember, you have to look at the function and identify where the function is above or below the x-axis. In this case, the entire function is below the x-axis, meaning that all of the intervals are negative. We could find all the negative intervals of each turning point for this function. The first negative interval is at when x is less than negative infinity and greater than negative 1. The second is when x is less than negative 1 and greater than positive 4. And finally, the third one is when x is less than 4 and greater than negative infinity. Now I will be identifying where the positive and negative intervals are for graph C. The first positive interval is when x is greater than negative 3. And the second is when x is greater than positive 1. And the negative interval is when x is less than negative 3 and greater than 1. Now we will be stating the positive and negative intervals for graph D. So there are 2 positive intervals and 1 negative interval. Again, I found this out by looking at the graph and observing where the function was below and above the x-axis. So the first positive interval is when x is less than negative infinity and greater than negative 5. And the second is when x is less than negative 5 and greater than 3. And the negative is when x is less than 3 and greater than negative infinity. Now that we are done answering questions 1 and 2, I have provided a photo of the written solutions so you can check your work as you have finished those 2 questions. For the last question, we will be explaining whether the graph might represent a polynomial function that has zeros of order 2 or of order 3. So, first I will explain what each of the orders look like. So the first order, the function will intersect with the x-intercept and go through the x-intercept. The second order, the function will touch the x-intercept and intersect with it, but it will not go through. It will just touch it and then move in a different direction. And the third order is when the function will touch the x-intercept and sit there on the x-intercept. So for graph A, it is in order 1 because the line cuts through the point, but if we were to make it in order 2, the line would just touch the point, and if it was order 3, it would just sit on the point. And when I say point, I am again referring to the x-intercepts. When identifying if a function, or I should rather say polynomial, has an order 1, 2, or 3, we are first going to look at the x-intercepts. So for graph B, there are 2 x-intercepts, one at -1, 0, and one at +4, 0. When we look at the function and we see how it reacts when it touches the 2 x-intercepts, we can see that the line approaches the x-intercept and touches it and intersects at the x-intercept point, and then it moves into an opposite direction. So we know that it is order 2 from this observation. If we wanted to make it order 3, again, the function would have to sit on the x-intercept when it would intersect with that point. For graph C, it has both order 1 and order 3. When we look at the graph, we can tell that there are two x-intercepts. So for order 1, the line cuts through the x-intercept -3, 0, and at the x-intercept +1, 0, the function, or you could say the line, sits on the x-intercept when it intersects with the x-intercept, making it an order 3. It could have been order 2 if the line touched the x-intercept and then moved in the opposite direction. Finally, for the final question of this solution project, we will be identifying which orders apply to graph D. So looking at graph D, we can identify that there are two x-intercepts. The first at -5, 0, where the function touches the x-intercept, making it order 2 because it only touches. And at the second x-intercept, where it is at +3, 0, the line cuts through the point, making it order 1. In order to make any of these points in order 3, the line, or otherwise known as the function, would have to sit on one of the x-intercepts.